Hi everyone, all of you. Good evening everyone. How are you all guys? All of you. Good evening everyone. Good evening all of you. Right. Audio video both are clear. Somebody just check it. All formula revision of which one? This highway engineering. We'll continue our discussion on this all formula revision of this highway engineering. Right. Okay. So today we'll be discussing which one? This rigid payments, right? That flexible payment formula will be completing, and rigid payment will start discussing if you just observe. You can say it's not rigid payment will be discussing if you just observe, right? That flexible payment will be making it over, right? Now all of you, everyone, welcome to Unacademy. Let's crack it, right? Whenever you are subscribing for the plus and iconic courses, don't forget to use the referral code RP Civil Live, right? All of you, which code you have to use? RP Civil Live is a referral code you have to use always, right? So this is my profile, you can follow me, and if you wanted to follow my profile in Unacademy, what you need to do is there one blue color banner is pinned by Unacademy Accord GATE and ESE, that is there na. Just click on that, you will be redirected to my profile in Unacademy. Okay, and whenever you are subscribing for the plus and iconic courses, don't forget to use the referral code RP Civil Live. Okay, all of you. Now these are all the plus courses I'll be taking at present. Which one are running? That airport engineering is running every day at 3:30 p.m. to 4:30 p.m. and RCC is running at 7:30 p.m. to 9 p.m. Okay, so this mock test, right? All of you don't miss this mock test. January 2nd to January 30th, every Sunday at 9 a.m. you will be having this mock test, all of you. Okay, don't miss this then. When you just click on when you just scan this QR code now, you will be redirected to that mock test, or you can find the link in the description also for enrollment. And those who are preparing for this ESC interview, right? ESC 2021 interview, this is the last chance you are having, right? That is why the name is given as end game. So this is the panel for civil engineering, right? You will be attending which one? You will be attending which one? You will be attending the interview under this panel. Okay, just prepare yourself for this interview. Don't miss this, right? So now this is 16th January. How many of you attended this combat? Again on 23rd, right? Again next Sunday you will be having this combat event. You can say don't miss this, right? At present this offer is going on 12 plus 2. If you are taking 12 months subscription, you will be getting 2 months extra. These are the new batches starting on 19th January. This new batch is starting if you just observe. Okay, all of you. And coming to this foundation batches, and all these batches are started, you can say, right? Now these are the free courses I'm doing now. These are the plus courses I'm doing now. Okay, right? So all formula revision, which part you can say we are discussing today? That part 28 will be 28 will be discussing now. Yes, part 28 will be discussing in today's class, because what we have completed in that previous class, if you just remember, what we have completed in this previous class, we just remember that cumulative standard axle repetitions, right? That cumulative standard axles per lane calculation we have seen, and after this cumulative standard axle repetitions per lane, and after that what we have calculated, we have seen that this is your modulus na, resilient modulus na, yes or no? This is your resilient modulus MR we have calculated, yes na, for CBR 264 we have done, right? Now we'll be entering into which one? This is 265. Okay, today's class, this is lecture 28, 265 we'll be discussing. How can you discuss this 265? What is that, you can say? What is that you can say here? What is that you can get it from here if you just observe? What is that you can get it from here if you just observe? There are design methods, right? Akhil, good evening. So whenever it is a CBR method, right? As per this, which one? This as per this new IRC method, na? First one is your CBR method, right? Design based on this CBR method. What is the meaning of this design? Design is nothing but your calculation of what? This thickness of payment, na? That is your design, you can say. Okay, design of this flexible payment based on which method? CBR method, or you can also call it as your design charts method, old method. design charts method, you can say design charts method or old method or CBR method, right? It is not at all used, right? It is not at all used, right? What are the disadvantages, you can say? Here if we just observe, here if we just observe, number na, yes Lena, that is number we are following na, 264, 265, right? This is your 265th number na. Every one new point or new formula we are writing we are writing one number, yes na. Good evening Padma, right? Yes, Akhil, I have taken almost 7 classes or 8 classes I have taken for traffic. Okay, just to check it in the plus course, you will be finding, right? Now, design based on this is CBR, right? What is that you can say based on this design charts? If you just observe, so this is your thickness, and what is that x-axis? That is your CBR value. But is it exactly that CBR value, or this is CBR value on the log scale? That CBR value on the log scale you are having, right? That CBR value on the log scale we are having, right? Now tell me, thickness and CBR are directly proportional or inversely proportional, you can say? Thickness and CBR are directly proportional or inversely proportional, you can say? Inversely proportional, you can say. Just for an example, right? If you consider these are the curves we are having, various curves are present like this. After plus means I have added in the plus course only. Akhil, I have added in the plus course only. I did not take it. Okay, in special classes, 1 or 2 special classes I have taken. Just to check it, right? 1 or 2 special classes I have taken. You can just check in my blog. Yeah. You can check in my blog, or you can check in which one, you can check in that plus course itself, right? You can just contact me after the class, otherwise I'll tell you. Okay, I'll let you know. Contact me after the class, Akhil. Right. So this is your curve A, this is your curve B, this is your curve C, like that we are getting, right? Curve D, or reverse it is, or whatever it is, right? A, B, C, D curves we are having. These are the different curves we are having, you can say. Let us say this is your curve A, curve B, curve C, curve D, like that EF are there. What are these curves corresponding to? If you just observe that a curve A is corresponding to which one? This is 0 to 15 CVPD, commercial vehicles per day. And curve B is corresponding to which one? This is 16 to this 45 commercial vehicles per day. Like that, what is that you are having? Curve F you are having. Now tell me, it is just based on, right? It is just based on what you can say? It is just based on this one day traffic only. Now can we select this based on this one day traffic, or it is impossible to select based on this one day traffic, all of you? It is impossible to select based on this one day traffic, na? It is impossible to select this based on this one day traffic, right? So is it considering the repetitions or not repetitions? It is not considering based on the repetitions, na? Lifetime repetitions of these loads we are not considering anywhere. Now let us say this is your curve B selected for our traffic, and for this curve B, for this CBR you are getting some value, na? For this CBR you are getting some value, and what is that you are getting here? Let us say you are getting which value? You are getting this thickness H, that's it. Or you can also consider this curve like this, right? The curves will be in this manner, you can say, right? The curves will be in this manner, you can say, otherwise. Okay, the curves will be in this manner, right? This is your CBR log scale, and this is your thickness of pavement, right? First what we need to do, among this ABCD curves, right? Among this ABCD curves, right? This is A, this is B, this is C, this is D. You select one curve. Let us say B curve is corresponding to our traffic. If you just observe, then corresponding to this B curve, get the CBR value and a log CBR value you calculated. That is your CBR value now. And corresponding to this, what you do, just drop a horizontal, you'll be getting the thickness, right? Now tell me, it is a simple method or very difficult method, all of you? It is just very simple method or very difficult method, all of you? It is a very just simple method, na? It is very just simple method, you can say, right? But it is not considering the vehicle damage effect, it is not considering the repetition effect of these loads, and it is not at all considering the lane distribution effect, and all these effects are not at all considered, na? Then is it okay to use this method or not okay to use this method? It is not at all okay to use this method. Okay, it is not at all okay to use this method. Which method we have to use? we have to use this IRC method or modified CBR method, right? So that is your 266. What is that you can say? IRC method, or you can also call it as which one? This modified CBR method. IRC method or modified CBR method, right? In this modified CBR method, what is that you are having? This is also very simple method only. This is also very simple method only. But what you are having is, on x-axis you will be having this cumulative standard axial repetitions in terms of this million standard axial repetitions, right? In terms of which one? This million standard axial, right? Not in terms of thousands, not in terms of different values, right? It is in terms of millions, right? And what is that you can say? On this you are getting this thickness y-axis, and this plate or this diagram is corresponding to, let us say, that is CBR 2%, right? Mean for CBR 2 1 graph, CBR 3 2.5 1 graph, CBR 3 1 graph, CBR 3.5 1 graph, CBR 4 1 graph, CBR 4.5 1 graph, like that you are having. Okay, this is 0, 10, 20, 30, 40, 50, like that for 10 million standard axles, 20 million standard axles, 30 million standard axles, like that you are having if you just observe. Now what you are there here? You will be having a bar chart here. You will be having which one? Bar charts are available, all of you, if you just observe. Okay, these bar charts are available, right? From these bar charts, what we are doing? We will be getting, right? Let us say it is for 30 million standard axles. Let us say it is for 30 million standard axles, that the top layers, it is divided into different layers, if you just observe. Whenever it is divided into different layers, let us say this is your H1 top layer, this is your H2 second layer, this is the thickness H3 third layer, this is the thickness H4 fourth layer, this is the thickness H5 fifth layer, like that you are having, right? Whenever you are having the pavement like this also, what is that? Different layers of this pavement you are having. This top thickness directly you are getting from there. Here second layer thickness you are getting directly from here. Third layer thickness you are directly getting from here. And fourth layer and fifth layer. How many layers we are utilizing? That many layers thickness you will be getting directly. Okay, H4 and H5. Now compared to the previous method, it is much more easier now. Compared to the previous method, it is much more easier, or not, all of you? Yes, absolutely. Compared to the previous method, it is much more easier, right? Compared to the previous method, it is much more easier, we can say, if you just observe, isn't it? Right, like that. Now 267, if you just say. So this is how we'll be getting the thickness, right? Now here cumulative standard axial repetitions per the entire lifetime of n years we are considering na. So repetition of vehicles or repetition of roads in the lifetime, vehicle damage factor is included. So means damaging effect of individual vehicles is included, lane distribution factor is included, means distribution of the traffic onto different lanes is included, right? All these effects are included na in this. Yes, all these effects are definitely included in this, you can say, yes na. Right, now what is it you can say? If you consider this a fatigue cracking, what are the failure criteria, as you can say? Fatigue and rutting only, no? Yes. What is that fatigue cracking, we can say, if we just say? Right. So it means when you can say it is a fatigue cracking is 10%, right? 10% of the area. Sometimes it is lagging, you just refresh it, Lasya. Once it is lagging, just close the session and again open it. Let's say if it is lagging na, just close it and open it, right? Just close it and open it, right? That would, it will work out then. Okay, 10% of the area may be having which one? 20% cracks. 10% area will be having this 20% cracks, 20% cracks, right? So 20% cracks, then it is your 90% reliability, right? Then it is called as which one? This 90% reliability, because only 10% area will be having the 20% cracks na. And suppose if you are having this 20% surface area may be having this 20% cracks, then it is called with which name? 80% reliability criteria na. So there are two criteria, right? 90% reliability criteria and 80% reliability criteria. You can get it, right? Yes, now 90% reliability criteria or 80%. So 10% surface area is only subjected to cracking. Yes, now let us say 1 kilometer, let us say 1000 kilometer square is a, this total area will be, let us say 1000 kilometer square. 10% out of this 1000 kilometer square, what is that you can say? 10% out of this 1000 kilometer square means 10 meter square. 10% out of this 1000 meter square is 10 meter square. In this 10 meter square area, if 2 meters area is subjected to, if 2 meters of this 2 square meters of this surface area is subjected to cracks, then you can say that it is fatigue failure. Is na? Out of this 1000 entire total length of the road, if 10% area will be subjected to cracks, 20% area is not subjected to 90% area is safe, then it is 90% reliability. Next, out of this 1000 square meter, only 200 square meter is subjected to, just for an example we'll say, right? 200 square meter, yes, 100 correct for that. Out of this 1000, if a 200 square meter area, in this 200 square meter area also 20% of this 200, 20% of this 200 means 40 square meter area, right? So if that is subjected to, right, if that is subjected to cracking, then you can say that it is subjected to failure, right? 80% reliability you can say, yes, na? Right. Now why this will occur? Whenever your load is applied, it will be deforming like this. Load will go off, it will go. Load will be applied, again it will be deforming. Load will be taken off, it will be like this. Whenever this repetitions of this loads are occurring, surface is subjected to cracking. That surface cracking due to repetition of loads is called as what? Surface cracking due to repetition of loads is called as what? Fatigue cracking or fatigue failure, right? So now tell me, just for one vehicle itself, right? Just for one vehicle itself, it is possible to create this much amount of cracking, or many number of repetitions are required to create this cracking? Many number of repetitions are required na? Many number of repetitions are required na? Yes, many number of repetitions are required. So what is that fatigue life you can say? What is that fatigue life? That fatigue life is your NF you can say, right? Fatigue life is nothing but your fatigue life is nothing but your which one? This it is a number of equivalent standard axle repetitions. It is a number of equivalent standard axle repetitions required for which purpose? Required for which purpose? Required to cause the above failure, right? What is the failure? 90% reliability if you are designing, 10% surface area will be subjected to cracking. In that 10% area also, that 20% area should be having cracking, remaining 80% not cracking. Is not required to cause which one? Above failure. There is a formula for this, but I am not going to write this formula, but you have to remember what is that. What is that you have to remember? On which parameters that NF is dependent on, you have to remember, okay? NF depends on which parameters, all of you? NF depends on which parameters, all of you? Right, NF depends on which parameter, all of you? That fatigue life is depending upon it. That fatigue life is depending upon. So now tell me, it is a horizontal cracking or vertical cracking? It is a horizontal cracking na? And which layer is subjected to cracking? This surface bituminous course is subjected to cracking na? This bituminous course, right? This bituminous concrete, right? This bituminous concrete layer is only subjected to cracking na mainly, right? Bituminous concrete is only subjected to cracking, right? So at this place, what is that bottom, right? Horizontal strain, right? It is depending upon which parameters you can say? Depending upon which parameters? First one is your maximum horizontal tensile strain, because how much maximum tensile strain it can take. If it is capable of taking more amount of tensile strain at the bottom, this bituminous concrete, more amount of strain it can take means less cracking. Less amount of strain only it can take means easy cracking. Yes, na? So that tensile strength, tensile strain or strain, maximum horizontal tensile strain at the bottom of bituminous concrete is important, na? At the bottom of which one? This bituminous concrete is important. Now top layer, bottom of the top layer, right? And also which one? It's a elastic property also, no? Elastic modulus of what? This bituminous concrete layer. Because if it is having that more elasticity, na, even for a more number of repetitions also, this permanent deformations will not occur, right? Permanent deformations will not occur. It's elastic properties as well as the maximum horizontal tensile strength it can take. These two will only influence its fatigue strength, na, fatigue life, you can say, right? Like that, is na? Now 268, this is your 269. What is that 269? Just simply what is that you can say? Let us say this is the total area of the pavement available. In this total area, let us say this is the 10%. In this 10% also you will be having this interconnected cracks. Na? This cracks, 100% cracking is possible. 100% cracking is not possible. Na? 100% cracking is not possible. Right? Let us say meter square. And out of this 1000 meter square, what is this 10% reliability means? 10% reliability first criteria means this is your 100 meter square, right? Out of this 100 meter square also, these cracks are propagated for which one? This 10 meter square, right? Cracks are propagated for this 10 meter square, right? Then you can say it is a failure. Yes, now is that clear, all of you? Fatigue failure. No. 269, rutting failure. What is the meaning of this rutting failure, you can say? What is a rutting failure, you can say? Whenever you, what is that rutting, you can say? Whenever your vehicle is moving on like this, na, automatically what happens? If your vehicle is continuously moving over the same location, especially in our villages, due to this bullock cart and all these things, do you observe this? It will be subjected to a depression here. Did you observe this depression? These depressions will be carried over, and finally who is supposed to take these depressions? This is subgrade soil only, no? Now tell me, the subgrade soil vertical strain capability is useful, or horizontal strain capability is useful in resisting the rutting? Vertical strain capability is useful, na? Yes or no? Yes, yes, depression in pavements, right? Yes, inspiration zone, good evening, right? Yes, depression in pavement, right? When this depression is called as your failure? When this 20 millimeter depression is having, then you can say it is a rutting failure, right? If that 20 millimeter depression occurs, then you can say it is failure. Then if it is a 20, is 20 meter square, then, right? If 20% of the surface area is subject to cracking, then it is static failure. Okay, like that. Now what is that rutting failure, you can say? 90% reliability means what? Huh? Yeah, tractor from wheels. Yes, correct. 10% of this length of road may be expected to have what? May be expected to have which one? This 20 millimeter depression. 20 millimeter depression, 20 millimeter depression, right? So 10% area is subjected to failure, right? Suppose if it is 20% of this length of the road or area length of the road may be expected to have this 20 mm depression. Having a 20 mm depression is failure, right? When you can say first one, that first one, can we say it as your 90% reliability design? Can we say it is your 90% reliability? Because only 10% of the length is subjected to rutting failure, because rutting failure is nothing but 20 mm depression. Only 10% of the length, right? Out of this 1 kilometer, only which one, this 100 meters length is having this 20 mm depression, then you can say it is 90% reliability, 10% failure. Here 20% of the length is subjected to depression and 80% is non-subjected to any depression, then it is, you can say, 80% reliability na? So there are two designs we are having, either it is 80% reliability or 90% reliability. You can choose any one, right? You can choose which one, any one among these two, all of you, if you just observe. Is it clear? Right? Now rutting life also, how can you get this rutting life now? How can you get this rutting life? N suffix R na? N suffix R is the symbol we have given for this rutting life, right? What is that rutting life? You can say it is nothing but your, it is a number of equivalent standard axles. Only one vehicle moving, will it cause that damage? Will it cause that damage, or many number of vehicles are supposed to move to cause the damage? Many number of vehicles na? So many number of repetitions, right? Number of equivalent standard axle repetitions number of TIONS, right? Repetitions, number of equivalent standard axle repetitions required for which purpose? Required to cause what? Above failure. Required to cause this above failure, right? Required to cause this above failure, right? Now tell me, finally all these are transferred to the subgrade. So here that NR depends on what? NR depends on which one? Maximum vertical subgrade strain na? That's it. There is a gate question from these 2 points, all of you. Don't think that RIR, sir, are these points important for gate? Yes, absolutely, right? For in gate you are having questions from this, right? In ESE also you are having questions from this, right? This is 268 and 269, 270, 268, 970. From these 3 or 4 formulas, you are having which one? Already questions, right? You are already having questions from this, you can say, if you just observe of you, okay? Already questions were there from here, right? So don't neglect these points also, right? With this, what happened? That flexible pavement questions got completed, okay? Flexible pavement formulas and flexible pavement important points got completed, you can say, if you just observe. Is that clear, everyone? Right? Okay. I'll be closing the session. Again, we'll be meeting in the next class with rigid pavement on which one? This is 20th, right? We'll be meeting on 20th January. We'll be meeting with which one? Lecture 29. Rigid pavement, right? After rigid pavement, traffic only will be there. Okay, is that clear? Ram Del, just text me. I'll tell you what to do. What you can do is, I'll tell you in general. You can just inform them, right? You can just send a text message, right? You can just send a text message to which one? Right? A mail to this GATE official mail, or you can just contact them. So this is a situation what to do, right? When you got COVID, Ram?